Okay, so my latest blog post about GPT2, it's about this training set and the output produced by the training set. And so this actual program, if you run it, and if you have 8 hardware threads, then it'll run like I'm gonna run it. So it's gonna load in a bunch of the test text, and then it's going to try to just generate more text. And so when it first starts running, it has to like sort of spool all of the input, and that has been done already. And now it's continuing to what's a process called feedmore, and this is what the program writes right now. So we're going to watch this for a moment. We're going to look at this, and then we're going to look at the code. So this program, it's got this namespace network lib. Inside it there's a function time, used to time functions. There's a parallel structure. It's very simple. It handles the parallel nature of the program, and it takes a constant, hardware threads. So you would set this to whatever your hardware threads is. And then the actual GPT2 model, it has a bunch of constants in this area. It's got its error object. It can have a file not found. It declares these parallel objects. It has parallel inputs and parallel heads. Okay. It's got all the network information. Which is... So when this program runs, it reads the safe tensors, it gets the decoder, it reads the encoder, so now it has the collection of all the GPT2 token and word knowledge for reading the encoder, and then it reads data. This is the test data file, which is about First Citizen. So then it takes the tokens and a certain amount of tokens, and the maximum amount of tokens that the model can accept is test input size. So we don't want to accept the maximum amount, so we accept or start out with the maximum amount. So you go test input size times 90%. So now tokens view is printed by decoding all the tokens into a string, and that looks like this area up here. This is all tokens view. And then the generated text is down here, which is sliding. The slide is producing this generating text. And slide consists of making sure that the input tokens does not exceed the test input size, and if it does, it gets the tail of the tokens, input tokens only. And then it has this for loop, or it encounters this function feedforward. feed forward takes all the tokens and it causes them to all spool into the data. All the information from all the tokens is spooled in, and that returns a token, which is the prediction. And then there's this function add token. And so a token is pushed back onto the existing tokens. So it is appended and then written to the screen. So that's what this process is. It's writing these added tokens to the screen. And once the token size has been increased to the total test input size, which is the maximum size, instead of pushing them back, it shifts all the existing tokens to the left by a certain distance and then resizes by that distance. So essentially, it shifts all the tokens by a distance and then shrinks a bunch. And then returns scrolled. So if scrolled is true, then you want to call feed forward, which means you have to spool everything back into the network. But if scrolled is false, it means you have room for another prediction. And so all you need to do is make one more prediction. And all the data for the previous prediction is still there. So this feedmore is very fast. In feedmore, so that's the end of this video. If you run this program, it works on an 8-thread processor in real time, basically.